In this segment of electricity, we are going to discuss about the resistance of a system of resistors. The two methods of joining the system of resistors are series connection and parallel connection. Here the resistors are the bulbs. When the resistors are joined end to end, then they are said to be in series. This is a circuit diagram showing the resistors in series combination. The circuit consists of a battery consisting of 4 cells, the negative end of which is connected to the plug key, which is connected to the set of resistors at the point Y. The positive end of the battery is connected to the positive terminal of the ammeter. The negative end of the ammeter is connected to the set of resistors at the other end at the point X. The three resistors of resistances R1, R2 and R3 are connected end to end between the point X and Y, which is called as a series connection. The voltmeter is connected across the three resistors in parallel at the point X and Y. The total potential difference across a combination of resistors in series is equal to the sum of the potential difference across the individual resistors. That is, the total potential difference through the series circuit is 6 volt, which is equal to the sum of the potential difference across the individual resistors. That is 3 volt plus 3 volt, which is equal to 6 volt. Irrespective of the resistances offered by the resistors, the ammeter shows the same reading across a combination of resistors connected in series, since the current flowing through each of the resistors is the same. Let's discuss the derivation for the resistance of combination of resistors in series. If the current through the circuit is I, the potential difference through each of the three resistors joined in series are V1, V2 and V3 of resistances R1, R2 and R3. Applying Ohm's law to each of the three resistors, V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. When resistors are connected in series, potential difference gets added. That is, V is equal to V1 plus V2 plus V3. If the three resistors are replaced by a single resistor of resistance Rs such that the potential difference is V, applying Ohm's law, V is equal to IRS. Considering the second equation, V is equal to V1 plus V2 plus V3. Substituting the values from the first and the third equation, IRS is equal to IR1 plus IR2 plus IR3. Taking out I as common, IRS is equal to I into R1 plus R2 plus R3. Cancelling I on both sides, RS is equal to R1 plus R2 plus R3. That is, when the resistors are connected in series, the resistances gets added up. Thus, when the resistors are joined in series, the resistance of the combination RS is greater than any individual resistance. Now let's discuss about the combination of resistors in parallel. Resistors are said to be in parallel connection if their terminals are connected to the same two nodes. This is a circuit diagram showing resistors in parallel combination. The circuit consists of a battery consisting of 4 cells, the negative end of which is connected to the plug key, which is connected to the negative end of the ammeter. The positive end of the ammeter is connected to the set of resistors at the point Y. The positive terminal of the battery is connected to the set of resistors at the other end at the point X. The three resistors of resistances R1, R2 and R3 are connected across each other between the common point X and Y. The voltmeter is also connected across the three resistors at the common point X and Y, which is called as a parallel combination. The total potential difference across a combination of resistors in parallel is equal to the potential difference across each of the resistors. That is, the total potential difference through the parallel circuit is 6 volt and the potential difference through each of the resistors in parallel connection is also 6 volt each. In a parallel circuit, the ammeter shows different reading through each of the resistors. since a parallel circuit divides the current through the resistors, which allows the required current to flow through the resistors. Thus, the sum of the currents through each of the resistors is equal to the total current. Let's discuss the derivation for the resistance of the combination of resistors in parallel. Connecting the voltmeter and ammeter through the resistors, let's note the readings. The current I through the circuit is divided to the three resistors as I1, I2 and I3. Hence, the total current I is equal to I1 plus I2 plus I3. Applying Ohm's law to each of the three resistors of resistances R1, R2 and R3 and having potential difference V, we get I1 is equal to V upon R1, I2 is equal to V upon R2, I3 is equal to V upon R3. Replacing the three resistors by a single resistor of resistance Rp and having the same potential difference V and the current through the circuit as I, we get I is equal to V upon Rp. Substituting the second and the third equation, in equation 1 we get V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. Taking V as common, V upon Rp is equal to V into 1 upon R1 plus 1 upon R2 plus 1 upon R3. Cancelling V on both sides, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Thus, the total resistance in a parallel circuit is decreased. The reciprocal of the equivalent resistance of a group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistances. Let's discuss the disadvantages of series connection. In series circuit, the flow of current is same throughout the circuit. Hence, it is quite impracticable to connect an electric bulb and an electric heater in series. Adding resistors in series increases resistance. Thus, if more lights are added, they become dimmer and dimmer. In series connection, even if one component or gadget fails, the circuit is broken and none of the component works. Example, the fairy lights used for decoration gets fused even if one bulb in the series becomes a dead bulb. Now let's discuss the advantages of parallel connection. A parallel circuit divides the current through each of the resistors, therefore the required current flows through the electrical gadgets. Adding a resistor in parallel circuit decreases resistance. This is helpful when each gadget has different resistance and requires different current to operate properly. In parallel combination, even if one component fails, the other electrical gadgets continue to work. In series circuit, if one electrical gadget fails to work, the circuit breaks and allows none of the gadgets to work. On the contrary, in parallel circuit, even if one gadget fails to work, allows the other gadgets to continue to work. That is why parallel circuit is preferred for domestic circuits. Well, now let's discuss why the ammeter is always connected in series with the circuit and the voltmeter in parallel with the resistor. An ammeter offers low resistance, so it is connected in series that enables to measure the current that flows through the circuit. But if it is connected in parallel, its resistance would further decrease and more current would flow through it that would lead to short circuit. While the voltmeter offers high resistance, so if it is connected in parallel, its resistance decreases, that enables to measure the voltage. But if it is connected in series, most of the current would flow through the voltmeter as series connection further increases its resistance and would not allow the current to flow through the circuit. Hope you understood the concept of resistance of a system of resistors in series and parallel combination. Thank you.